Welcome back. This is part 2, operators. In this lesson, we'll look at the assignment operator, which we've already seen, as well as several arithmetic operators that allow you to add, subtract, divide, and multiply, and advanced operations using the math library. We'll look at how to combine strings using concatenation, and how to access individual properties in an object and individual elements in an array. Operators are symbols that can be combined with variables and values to produce new results. We've already seen one operator, the assignment operator. When we declare a variable and set it equal to an initial value, it's taking the value on the right-hand side and placing it into the value on the variable on the left-hand side. We also have arithmetic operators, addition, subtraction, multiplication, and division, using the plus and minus symbol for addition and subtraction. For multiplication, we use the asterisk, and for division, we use the /. These operators can be combined with either variables or literals to produce new results. They also have the same order of precedence as in algebra, with multiplication and division being evaluated first, and addition and subtraction being evaluated second. You can also combine expressions with parentheses to change this order of evaluation. Let's take a look at a few examples. I've already declared several variables. Let's go ahead and combine them with some of the operations that we just looked at. I'll set x equal to the sum of a and b. X is equal to a plus b with a semicolon. The value, of course, is 30, since the variable a contains the value 10 and the variable b contains the value 20. We can also do subtraction. A minus b should give us a value of -10. We can also multiply values together. X is equal to a times b, which should give us the value 200. You can also combine these operations with literals. Let's add 5 to a. X is equal to a plus 5. That should give us a value of 15. The order of the operands is unimportant. That is, it's commutative. A plus 5 is the same thing as 5 plus a. You can combine these operations with multiple variables so that we can take the sum of all three of these variables, a plus b plus c, giving us the value 32.5. Remember that the order of operations is just as in algebra. So if I say a plus b times c, b times c is evaluated first, giving us 60. This is different than if we add a and b together before the multiplication. More complex operations can be performed using the math library. It provides several useful constants and calculator functions for you to use. You can access this functionality by typing math dot, followed by what you want. For example, there are several constants like pi and e. Math.pi, math.e gives you these values. There are also several functions like the square root function, the sine function, and the pow function. A complete list can be found at the link here. The input is provided inside the parentheses, and the output can be used in larger expressions or be stored into a variable. Let's take a look. Let's compute the area of a circle with radius 1.5. I've already created a variable called radius and set it equal to 1.5. Pi r squared is the formula for area, so let's create radius times, now let's use the math definition of pi. Math.pi. 7.06 followed by a lot of numbers. Alternatively, we could have used the math library's pow function, short for power, to compute the square. Area is equal to math.pow. Pow takes two arguments. The first argument is the base, radius, and the second argument is the exponent, in this case 2, since we want to square it. Same result. You also have access to several trigonometric functions like sine. Let's create another variable. Let's go ahead and find out what the sine of 0 is. It should be 0. Let's try that again with, say, 90 degrees. We should get 1, but we don't. We get something close to 1. Let's try that again. But let's use math dot pi divided by 2. That's 1. The trigonometric functions in the standard math library expect all of its arguments to be in radians, where 360 degrees is equal to 1 radian. So 90 degrees would be 2 pi divided by 4, or in this case, pi divided by 2. Let's try that again with 180 degrees. We don't get the answer that we would expect. But when we try it with pi, we should get 0, but we don't. We get something very, very close to 0. This is because of floating point errors and the fact that computers are finite objects. We'll discuss this later in our exercises. As a final example, let's take a look at the standard math library's square root function. Math.sqrt. Note that it's shortened. We can compute the square root of 2. Let's use this in a larger problem. Suppose that I've got 3 variables, a being 5, b being 10, c being 3. Now suppose that these are variables in a quadratic polynomial, and we want to solve for the roots using the quadratic formula. X is equal to negative b plus minus. We can't do that, so let's go ahead and just do the plus root. Math.sqrt b squared, so b times b, or we could reuse the POW function, minus 4ac, 4 times a times c, all over 2a. String concatenation is the operation of combining 2 strings together, appending one to the end of the other. To do this in JavaScript, you use the plus symbol. For example, if I have 2 strings, Java and script, I can combine them into one string, JavaScript, by simply putting a plus between them. It's the same symbol as addition, but when used in the context of strings, it's interpreted as a concatenation. You can mix numbers and strings to convert the numbers to strings for the purposes of, say, printing them out. Let's take a look at an example. Let me go ahead and create a couple of variables. A string variable to hold the string hello, another string variable to hold the string world. Now let's create another variable and set it equal to the concatenation of hello world with a space in between them. S, concatenate a string literal space, concatenate T. The result is hello world now with a space in between them. Again, you can also combine numbers and strings to form new strings. Let's create another variable, x, set it equal to 10. And we'll reset m to be a string with the message, the value of x is, and then concatenate that with the variable x, giving us the value of x is 10. The value stored in the concatenated variable is converted to a string for the purposes of string concatenation. You can also concatenate strings directly as function arguments. For example, console.log. If we want to print out the value of a variable to the console, we don't need to store it off into a temporary variable. Instead, we can do it directly. The dot accessor allows you to access or modify an attribute of an object. The syntax is simply the reference to the object, followed by a period, and then the key that you want to access. Here's that student object that we saw before. Student dot first name gives me access to the first name, Chris. Student dot last name gives me access to the last name, Burke. You can combine these to form new strings. For example, let's go ahead and create a name variable and set it equal to student.lastname concatenated with a comma space student.firstname, giving us Burke, comma, space, Chris. You can also reset the values of the variable. For example, student.gpa is equal to 3.5. That changes the value. To show this, let's go ahead and print out the student to the console. When we do, we can see that it's printed an object. When we expand that, we see that the first name is Chris, the last name is still Burke, but the GPA has now changed to 3.5. Elements of an array can be accessed or modified by indexing them. To do this, we simply take the name of the array and follow it with a square bracket. Inside the square brackets, we provide the index for the element that we want to access. The first element is indexed by 0. The second element is indexed at 1, etc. So the last element is indexed at array.length -1. Attempting to access invalid indices may result in undefined operations. Here, as an example, I've created an array containing 5, 9, 42, 2, 8, 4, 4, and 3. Altogether, it has 8 elements. The first element is at index 0. So ARR sub 0 should give us a value of 5. The second element is at index 1. So ARR sub 1 should give us a value of 9. The last element would be the 8th element, but because we start at 0, it'll be at index 7, giving us 3. Alternatively, we could have used the .length property of the array sub array.length -1, giving us the value of 3. You can change the value of individual elements by using the usual syntax. Let's change the first element to 10. ARR sub 0, we'll set that equal to 10 using the assignment operator. Now when I come back up here, it's changed to 10. Let's set the last element to 30. ARR sub array.length -1 is equal to 30. When we come back up here and reevaluate it, it's been changed to 30. Again, attempting to access invalid elements may result in undefined behavior. For example, ARR sub -1 is undefined. ARR sub 10 is also undefined. Using these in other expressions may result in odd results. For example, let's create a variable x and set it equal to ARR sub -1 plus 5. The result is nan, not a number. That's because you can't add 5 to something that doesn't exist. An undefined value is treated as not a number.